So in this lesson I want to continue our work on the principle of conservation of energy and look at a couple of problems involving circular motion and maybe bring in the trig functions at some stage. Okay. So I have this question: a swing when at its lowest point is 1 meter above the ground. A girl sits on it and swings. When at her highest point the swing is 2 meters above the ground. Find the speed when the swing is at its lowest point. So we're going to be using the principle of conservation of energy, which says the total change in mechanical energy in a conservative system is zero. A conservative system is a system where the only force at work is gravity. So we're going to kind of look at this situation where the only force working on the swing is gravity. Of course, we're ignoring friction and some other things, so we're just imagining gravity as the only force at work on the swing. So what do we have? We've got the swing, at some stage it'll be its lowest point is when the swing is vertical, and then it swings around. It's kind of following a circular path. It's a very poor picture of a circle. It'll follow a circular path, and at some stage it'll be 2 meters above the ground. Okay, I want to find the speed when the swing is at its lowest point. So I want to, think about this maybe as being position 1, and this as being position 2. My principle of conservation of energy says the total energy at position 1 must be equal to the total energy at position 2. And energy is made up of potential energy and kinetic energy. Generally. So if we take position 1, if we look at position 1, if we kind of just give this, call that position 0, and then over here, this will have, if that height is position 0, that'll have a height of 1. Remember, that's 1 meter off the ground, that's 2 meters off the ground, but we can just say 0 and 1. So we're talking about the potential energy above this kind of point. This is my baseline here. If we look at the lower position here, when it's at its lowest position, we can ignore potential energy because it has no potential energy relative to this position here. So its potential energy is gone. So at position 1, all of its energy is going to be kinetic. At position 2, which is at our highest point, that means the swing will have stopped. If it's at the highest point, the swing will have stopped. So all of its energy at position 2 is going to be potential. So as the girl swings from position 1 to position 2, all of her energy is transferred from being kinetic energy into potential energy. So we have a half m times her initial velocity squared at this first position will equal to mg, potential energy, times the height at this second position, which we're going to just call 1. We could, of course, call 2, and then we would have to introduce the potential energy over here. As always, the masses will cancel. Doubling both sides will give me u squared equals 2g, so u is going to be equal to the square root of 2g. Okay, and the units there will be meters per second. So that is the speed of the girl at her lowest point, or the speed of the swing at its lowest point. Okay, so circular motion in this case. I'll look at one more example in my next lesson on circular motion there.